Hello again from Skip, Victor Echo 6, Bravo, Golf Tango, part 2 of the miniature dish project. I had a kind of a odd feeling the other day, saying to myself, you know, most people build a model or a scale model dish project first, then build a big one. Or I did it the other way around. I built the big one first, then I did the model one, so it's typical for me to do things backwards. So I left off in part 1, I got the new counterweights built and mounted, built out of lead and tubing. So the next step was to build a new wood base for it, a stand. So I'm looking at my pile of scrap wood, and I found 3 pieces of knotty pine that I laminated together. I cut a hole in the bottom of it through 2 of them, and this is where the azimuth motor is going to sit. Remember, the slew gear is a fake one, so got to turn it somehow. The block of wood got trimmed and router by a good friend of mine, thanks Bob, and then put the 4 bolts, the footings we would call it, and just set the stand on top. And it was at this point that I decided I'm not going to paint this thing. I was originally going to paint the dish and the stand just like the real one. The stand was going to be black, and I was going to spray paint the ribs silver, but I just liked the color of the brass, especially when the base gets stained. That was another problem, though. You think you could find paint that looks like brass that would cover over the ugly solder joints? Remember, I had solder gobs all over this thing. I had thought of I was going to spray paint everything, but now I'm going to leave it brass, so I can't have just a big gobs of solder hanging out there. So I had to go to an actual auto body paint supply and get a little bottle of paint mixed up. He did a nice job of it, and I covered over all the solder marks on the ribs, on the stand, everything. It turned out well. Okay, I kind of got ahead of myself here a little bit. It's right around this time that I decided it's time to build the small parts, the detail stuff, the feed, the junction enclosures, different things like that. I started off building the feed. I decided to go with 23 centimeters because it was the biggest, and built it out of copper pipe. Tried to keep it in scale. Even put out a small preamp on the side, and then a set of polarizing bolts. Some small little pieces of copper pipe coming out, which will later become the end connectors. I had to take a picture of this, the little miniature one beside the full-size one of my feed that I use. And I built it to slide into the feed mount that I had built on the dish earlier. Cute as a bug. Next little parts I built were the electrical enclosures. I milled these out of small blocks of aluminum. Some of them are actually going to have wires in them because I got to run wires up to the elevation motor. That, and then the main electrical enclosure, I used my small brake and bent a nice little box for it. Got it all mounted in the frame, and just got things in general fit. And when it was all done, I put them all together, and the slew gear taped off parts I didn't want painted and sprayed them my favorite color, gray. Well, finally it's here, the start of the last part of it all, the assembly. So with the wood base all nicely stained, I got all the parts and pieces laid out on the bench. I brought everything into the ham shack to do, set out in the garage now, and started looking at things to assemble. Like all miniature projects, it's getting your hands inside some of the places that just aren't made for big hands. So it's a bit tough getting them in there, but it's doable. Good thing to have a nice set of needle nose pliers, I guess. Then getting fancy using these little miniature lock nuts. You can see, instead of ordinary nuts, they just look better. Again, it's hard to get in there. But, oh well. I use a socket, but I don't think the socket would get in the way of the leg here, and I wouldn't be able to run it anyway, especially that one on the far side. It's really tight, so it's just one little crank at a time. Almost like the real footings on the real dish. This picture, you can see why I want to leave everything brass against the, the nicely stained base. It just looks really good. It was even at this point that I was even thinking I'm not even going to put mesh on it because I wasn't sure how I was going to do the mesh. But just being the framework all gold or brass colored, it looked really good. Next was the electrical enclosure box. I built a door for it, and it's darn difficult to manipulate. I got these, I don't know, I think 1mm screws, very small, and it's the hinge. I was originally not going to have a door on this thing, but I decided, well, yeah. So the nuts are itty bitty, and I darned if I can get my fingers on that, so gotta carefully just line them up. Oh boy. Oh, there's one, I think. Yep. Oops. We're still in focus here, yep. He's a itty bitty little thing. But, it's gonna work. Get that nut on there. I might, I don't think I'll double nut it. I think I'm just gonna either shear off those pins, the nuts, or put a dab of glue on. Haven't really quite decided yet, but see it closes up. Little electrical box. Cute as it could be. Before I can mount that electrical box, the bigger one, I have to put this little one on. It's the box that would enclose the 24-volt power supply for the slew gear, and it bolts on the back plate, which is going to be the back plate for the electrical enclosure. So it's got to go on first. This is the fun part. It's got all these little fittings for the cablings and stuff, and it's a tight fit. So I'm gonna wiggle it in here like so. Yeah, that's right. Thought we had it in upside down there for a minute. Get in one hole, get it in the other hole. Believe me, I've had all this together before I painted it all, so I know it fits. Anyways, yeah, cute, eh? What a person will do for kicks. Again, a tight fit. Luckily, I got this goofy thing. Had this for years. Don't even know where I got it from, but it's the right size. Get in there. You gotta get the nut on and thread her in. Just like that. One down, 3 more to go. So this is the fun part. This RG174 is just the right size to emulate the 1-inch liquid tight flexible conduit. And it fits in there, and you can see the 2 wires hanging out. Well, I got to join them 2 together. This is going to be actually feeding the voltage up to the elevation actuator, so it's got to work. Next on the agenda was the slew gear. You can see in the different pictures here how it fits together, the slew gear body onto the mounting bracket, and then how it slides onto the frame. 4 little miniature, I think 1mm screws again, that hold it onto the main tower frame itself. Would have been rather cool to have it actually power the azimuth drive, but that's just asking too much. But it does have a special effect, so you'll see it. I figured painting the slew gear gray and then the rotating disc black with the drilled in holes for the bolts, showing the brass to it, looked rather good. Of course, what would the azimuth slew gear be without its azimuth encoder system? It's got 2 proximity switches, and they're wired into the little gray box, and the little star disc, or whatever you want to call it, on the end for the switches. It actually rotates. Next, I installed the vertical mast itself. I didn't take a video of it, but I got 2 pictures there anyways, and you can see the detail on it, and where I've got the imitation liquid tight conduit going up to the upper elevation box. This is, of course, where the elevation actuator is going to be wired into it. Again, working voltage. So I forgot to show putting the mast in, but oh well. I want to check the motor for rotating. So So I got leads hooked up down there. And it's spinning. Now I got the cable all twisted around here, but oh well, it's going to have to be reworked. Anyways, it seems to be doing its thing. I like the slew gear part of it. Change direction, go back. See if I can. Yeah. Anyways, pretty cool. Well, I was at a fork in the road. I had to make up my mind and decide what I was going to do about the mesh situation for the reflector. I said to myself earlier I was just going to go without mesh because it looked nice just with all the brass hardware. But I knew if I didn't try something, I'd regret it. So I had to try something. I decided to try what they call fiberglass mesh. It's just ordinary window screening, and the color of it being black against the brass would look good too. Plus, it's a lot more flexible than aluminum or steel mesh. But as soon as I cut it and laid it on the dish, so I could see it's going to be a big pain trying to get all the folds out of it. It's just going to be just like the big dish. I had a hard time keeping it flat too. So I got some of this glue, and I figured I'd try an experiment. I cut a small piece of mesh onto just a piece of tubing I had laying on a scrap piece, and just to see how it was going to hold. And this gel, I thought I'd squeeze it on there in little spots and then hold the mesh into it and just see how strong it was. It was going to hold, but the trick was trying to hold it down. It kept wanting to pull away, and that was the issue. So I thought I would try something like this. I bent a piece of aluminum, the same curve as the parabolic, and I put down the glue, and then I put this piece of aluminum strip on top with some weight and hold it down. Yeah, it worked great. Trouble is, it got glued to the rib also. So as soon as I pulled it away, it was pulling the mesh away. I don't know. It was. I tried different things, different weights and stuff, but nothing was going to work. Well, a good friend of mine, Gary, offered me his little bottle of glue that hardens by UV light. I've heard of this stuff, but I've never seen it. And man alive, this is the best stuff since sliced bread, I'll tell you. Okay, well, this is how I've been doing the mesh, and I've been doing some stupid things, but I don't know. What I've got here is this instant glue that works with a UV light, and in order to get this to stay down, to glue it completely, I was having troubles because the mesh doesn't want to lay in, and I'm using this other epoxy to really glue it down completely, but it's not instantaneous like they claim it is. So I was fighting with it. So I used this instant stuff, and what I was doing up till now, I don't know, I did about almost half of this before I realized I was doing this wrong. I was lifting up the mesh, getting on the rib, putting a couple dots here and there, and then I'd get it down and hit it with UV light. Well, bonehead I am. Why am I lifting it up for? Because I lift it up and it would just tear away. So I finally got clued in. Do it like I do with the other glue. Just put it on top. So I'll show you here. I put a little. I don't know if you might not be able to see this with the post-it note here. I don't know. But anyways, I just put a little dot on it, and I kind of worked it in a bit too to make sure it sticking. What I was finding, it wasn't sticking to the brass. And it's the first time I ever used this stuff. It's amazing. You hit it with UV light, and it goes hard as a rock instantly. And I'm just kind of amazed by that. So I just worked my way up. I make sure I kind of stretch this out a bit, and put a couple of dots in a few places here, one there, one there, and one there. Try and work it in a bit. Make sure it's sticking to the brass. Then I zap it. Oh, there goes my tool. The biggest problem is trying to see where the glue is too. That wasn't working out too well. Take care of that. Get my toothpick up here. My dental pick. But yeah, it holds it down. So it works good. So just make sure I lay it out flat. Put a couple more on here. I can't believe I was doing it the other way. Lifting up this mesh and squeezing it down in there. I mean, that's good grief. This is so much easier. I don't know what I was thinking about. I mean, this UV stuff is quite amazing. It just instantly holds it. And it's holding it down flat for me. Well, looks good. Okay, so the next step is here. Make sure to hold it flat. Give it a zap. And voila. If this would stick on it really well, that's all we'd have to do. But they say it's not really a glue; it's more of a filler. So I can believe it. So the trick is getting this laying down flat. It's just like the big dish, trying to get the mesh to lay flat. Well, I remember that headache I had with that hardware cloth. That was a real pain. I mean, it's going to be like the big dish. It isn't going to be perfect. But hey, it's just a model. There. And I usually do, good grief, this thing. And then I usually do this halfway stretch on here too. And it's holding it down. Now it just takes the stress off that. I'll put this on here if it'll stay there. No, not gonna. Okay. Be miserable. Yeah. So that part. Put the lid back on this. Now it's being held down flat. Yeah. Now I just take the super glue, crazy glue, and I just blob it along. And it soaks in nice. And this stuff really sticks. So it's not like the real dish where I used rivets everywhere. But what are you gonna do? It's just a scale model project. Then it's raising up a bit on the other side here, so I got these blocks of steel. I just put them on there to help it stay down while it's drying. So I'm gonna put this plate on here like this. Oh, I forgot about this side here. No, this is where I gotta go. Put this, oops, and that's what happens. Oh well. I know what I gotta do. Right. It's a good thing this stuff doesn't dry fast. Now, let's take a little. See that instant there, that UV light stuff didn't stick there. I'm not sure why. Sometimes it works better than it does, but Believe me, it's a lot easier. So I put just put a piece of wire on here, and then hold it down. What tape? It just stay there. Okay, I'll be miserable about it. And I'm just getting on the glue. Sure works good down here though. I'll just check it. My pick. Oh, see, it's not sticking down here. Okay. Put some more weight on it. There we go. That'll work. Right over here. Yep. Good. Give her 15 minutes and that'll be that. So that UV glue works, but I don't know, somehow it didn't hold there. Probably not, the brass is probably a little dirty or something. But it works for that part anyways. No. One rib at a time. So, a couple of days later, the mesh is all down, and boy, was I happy. The one thing I was really concerned with was the joint. When the two ends of this mesh come together, I had to cut it in order to get it to lay down flat, trim it, and I laid one on top of each other, right on top of that one piece of rib. It's only 0.1 of an inch across, and it turned out well. I just glued the living daylights out of it, and boy, it's a lot better than I thought it'd be. Then at this point, I flipped it over in the vise, got the dish sitting on its side sort of thing, so I could work on the loose ends, I guess to say. It's got to be folded over the side and glued. Okay, the next part. This seems to work, so we'll carry on. Loosen it up here, move it down a bit. So we got her clamped on end. So this, just between the ribs here. Crazy glue. Just clamp it on earlier clamps. Seems to do the job. Squish in there good. And let her set. Easy peasy. Worked better than I thought it would. So I glued it along and used lots of clamps. In fact, I even had some strips of wire in there to go between the ribs just to keep it all held down, and applied lots of glue and worked on it, and it turned out good. Alrighty. So the next step is carefully trimming the excess mesh off. And the last thing I want to do is cut into the mesh on the top. Watch this come undone here. Seems like the glue is holding, so far so good. Anyways, that's what it takes. And that's what it took. Well, I'm so glad I decided to mesh it in instead of just leaving it bare, because it just looks so much better. It just turned out way better than I'd ever dreamed it would. So you can tell I was quite happy. On to the next part. So with the mesh all finished, I flipped it over and started getting it prepared for mounting on top of the mast. Put the little square frame on the back of the dish, and here we go. The next big step is getting this big thing on the frame. So we got a bolt in there, it just fits on top. Get things lined up. There it goes, I think. Come on. There she is. Get too carried away, got another bolt in here. Slight misalignment. Almost as easy as a real one. One little trick here, because these little bars have to go on top. Oh boy. Not as easy. Believe me, it does fit. Yeah, that's in there. So what's going to be next is the little junction block has to go up in there, and I've got to figure out wiring distances up to the feed horn before I can bolt this thing in, because I've got to do connections in there. That's going to be tight. So next I got the feed arms mounted with a little tray at the end for the feed horn to sit in, because I needed all that there to figure out the cable lengths to run out there from the junction box. Getting that little junction box up in that spot with my big fingers was interesting. And then the, we'll call it the liquid tight, 1-inch liquid tight conduit, which is going to carry voltage up to the actuator. Had to get that slid up through the hole, and then I ran the wiring out to the feed horn from this junction box. Now this is just, prop wire. It's not doing anything out there. And it's probably a little bigger than scaling, but it looks good. And tied it all on there. And what I used for tie wraps was just small strips of electrician's tape. And I would wrap it around, and then I took some conformal coating and coated it so the ends wouldn't peel off, like tape always seems to do. Next I hung the elevation actuator, hooked it up to the back of the frame of the dish, and then ran the wires into that small junction box. You can see it sort of in there. It looks like a bit of a mess. I got the wires from the actuator connected to that small piece of coax. I've just insulated the center conductor because it doesn't matter if the other side touches the frame. And later on I'll cover that with a small piece of tinfoil tape. Trying to keep this thing true to form on top of the azimuth mounting plate. There's a little gray box that one of the elevation axis goes into. This is supposed to be replicating the elevation encoder gearing system. You can see the little blue cable come on off it, and it feeds down into that little junction box also. Next, for cabling and keeping true to the form of the scaling, I needed to run 2 wires up the side of the tower, which is going to simulate the heliax, 1 5/8 and 7/8. And it actually turned out quite well. I laid some small pieces of aluminum to try and make them look like end connectors for the 2 cables. Better than nothing. Then from the end connectors, we'll call them, the transition is over to the 1/2-inch Superflex. 2 lines of that, one for receive, one for transmit. And it wraps up around the mast, goes through the framework, and then out to the edge of the dish. Then the 2 runs of 1/2-inch Superflex are passed through the mesh, run up the arms of the feed mount, and then they hook onto the feed itself with some nice little end connectors, I guess. The other feed arm, you can see the two blue, we'll call them utility wires. They go up and hook into the small junction box that's underneath the dish, or the feed mount, I mean. And then you can see one of the jacks is having a small cable that's actually the power feed for the preamp, and it goes up into it. The other three jacks are capped off. Well, I couldn't believe it. It was finally done, except for a few other little things. But you know, the main part of it, I was just beside myself. I don't know what I'm going to do with myself. It's unreal. Well, okay, not quite finished. I had to build a control box to run this thing. So this is the little thing I put together. It's just got a 9-volt battery in it and a small pulse width modulation control circuit just to control the speeds. The little plug that plugs into the socket that's on the side of the wooden base. Then I had to crown it off with a name and spec plate for it. Hard to see it with the way it reflects the rest of the brass. I guess I should have picked a different color. Okie doke, more show and tell, and that'll be that, so enjoy. So, this is the finalized showing of it all. I forgot to show you a few little things here, which are really quite cute. I don't know if I can zoom in here or not. We'll try this. This is the main utility box. It does open up. And you can almost see inside it. It's actually got circuit boards in it, so it's kind of a cute little feature. I'll see if I can get a better shot of that. No, it's the best I could do. No matter what I tried, it just wouldn't. The picture wouldn't turn out. It's just a print of the actual control circuitry out on the big dish itself. So I just stuffed it in there on a piece of foam and bet it's just some ugly old wires. But couldn't get a picture of it. And away we rotate. Don't have any end stops, so I got to be careful of the cabling part. I don't want to wrap it up too tight. Now we'll go back around. Speed her up a little bit. Don't think you can see it there, but the slew gear does rotate. I'll zoom in on that later. That's stop right there. Almost sounds like it uses a bit more counterweight, doesn't it? One thing I've never tried is to turn it in both directions at the same time. Oh, look at that. Doesn't work. Yeah, little 9-volt battery. It's a little bit of a load for it, I think. And again, like I said, no end stops, so you gotta watch it. Got lots of travel on the actuator, though. It can go a long ways, but Just like the big dish, it's close. That's high enough. Okay. Take her down. This is where some of the mechanism chatters a little bit. I never quite figured that out, but I think it's just the angles of the worm screw. It binds a little bit, so it sits there and chatters when it gets closer to the 0 degrees. But it's good enough for the model. It means it works as good as it does, really. I'm impressed. You'll hear it bouncing here a little bit here soon. Yeah, we'll stop there. Oh. Bring her on here, one of these. Some more. Pretty wild. My biggest problem now is where I'm going to put this thing. And we're going to have a cable wrap up, so I better stop there. Anyways, it is pretty cute. Well, that just about wraps it up, finally. It was just like the big dish. It was a big project, only in 1/10 scale, I guess. Anyways, it was a lot of fun. I really enjoyed building this little thing. It's something I've always been wanting to do, so here we are. Anyways, thanks for watching, and hope you enjoyed as much as I did. 73 is now from Skip. Victor Echo 6, Bravo, Golf Tango.